All right, let's look at about 5 quadratic word problems in this video. I looked over a couple of them and we're looking for maximum, minimum, another maximum. So whenever you're doing these quadratic word problems and they're asking for maximum or minimum, I want you to remember that when you graph a parabola opening upward, here's the minimum right there. Minimum is the y value of the vertex, right? What about the maximum? If you have a parabola opening downward, well, that we call that the maximum, the highest value, and a maximum happens at vertex again. So whenever they're asking you for these minimum or maximum value, how do you minimize a unit cost? How do you maximize a profit? You're going to find the vertex. Okay, so remember that we're going to find the vertex. A ball is thrown vertically upward. So I'm going to throw a ball upward. After t seconds, its height h in feet is given by the function h of t equals 68t minus 16t squared. I like this function. This is a quadratic, but I would like to rewrite this. I would like to rewrite it so that negative 16t squared comes first because that's my quadratic term. And then I'll put my linear term, positive 68t, as a plus 68t. Why did I do that? So that I can easily identify. I mean, you don't have to rewrite it, but I like to keep things in standard form. So I can tell that A is negative 16 and B is 68. So they're asking, after how long will it reach its maximum height? They're asking you to find the maximum height. Or after how long will it reach? So either way, we should find the vertex. Find the vertex. Okay? The vertex formula is x equals negative b over 2a. X is the usual input, right? Like in an f of x is the input, but our function is h of t. So instead of calling it x equals, I guess I'll just call it t equals. That will give us the time, the number of seconds it will take to reach its maximum height. So if I plug in b is positive 68. So put negative 68 on the numerator. In the denominator, do 2 times negative 16. My calculator. 2 times negative 16 is negative 32. And let's divide. 68 divided by 32 is 2.125. And what does t stand for? Time, right? 2.125 seconds. What we really have to be careful about is, you know how vertex has 2 numbers, right? X coordinate and the Y coordinate. So they may be asking for the X coordinate or the Y coordinate. So we have to make sure that we read the problem again and to make sure that we answer the question. They said, after how long will it reach its maximum height? I can say after 2.125 seconds, it's going to reach its maximum height. If they ask you to find the actual height, if they wanted you to find the height, then you have to just plug that number into the height function. But they didn't want the maximum height. They just wanted to know how long will it take for it to get to the highest point. So we answer this question. So let's look at another one, number 2. A supply company manufactures soda machines. The unit cost C, the cost in dollars to make each soda machine, depends on the number of soda machines made. So cost is dependent and number of soda machine that we're making is independent because the cost depends on how many soda machines we make. Okay, let's see. If X machines are made, so whenever we see the variable X, let's remember that we're talking about the number of soda machines. If X machines are made, then the unit cost is given by the function. They're giving us a function. C of x equals 1.5, blah, blah, blah. So they gave us a standard quadratic function. Okay, we know how to work with that. I can tell that A is equal to 1.5. Everything is in order. B is equal to not 468, but negative 486. They're asking you this question. What is the minimum unit cost? Like I said, whenever you see these words, minimum or maximum, find the vertex. Okay, find the vertex. So I say x equals negative b over 2a. The numerator will be negative of that. So positive 486 divided by 2 times 1.5. What is 486 divided by 3? Let me see. 486 divided by 3 is 162. Now, what does X stand for? Because we just found the X. X stands for the, X stands for the number of soda machines. So, if they make 162 soda machines, they will be able to minimize the cost. But was that what they were asking? Let's read the question one more time. They said, what is the minimum unit cost? They don't really care about how many soda machines. Of course, we need to know how many we need to make. But what they care about, what they want to know is how much is that going to be? What is going to be the unit cost? So let us find the cost by plugging our answer, by our X values, into the cost function. So we're going to plug it in this time because they were not asking for the number of soda machines. They were asking for the unit cost. That's why we have to plug in. Okay, so if I plug in, I will have 1.5 times 162 squared minus 486 times 162 plus 85,241. And maybe a good question if you're wondering, how do I know when to plug in and how do I know if I can stop after finding the X coordinate of the vertex? And it really just depends on what they are asking. You should be able to, we must read the problem very carefully and we will not stop until we answer the question they asked. Okay, I got it. So the answer should be $45,875. That is going to be the minimum unit cost and the unit is in dollars. Okay, so doing good. So the first question that we answered was just stopping after finding the vertex, but then the second one we had to plug in. So like I said, sometimes, based on what they are asking, you're gonna have to do just one extra step. Let's do example 3, and then I'll take a quick break, and then I'll come back for the other page in another video. What's Lorenzo doing? Lorenzo has 100 meters of fencing and wishes to enclose a rectangular field. Let me draw a rectangle. When I think about rectangle, guys, I think about it like a little longer on the side. So that's my rectangle. So he has 100 meters. That's all he has, and he wants to use it all. Okay, and he's trying to make a rectangle. Suppose that a side length in meter of a field is x. One side is x. I will pick this side to be x. But what you know about rectangle, though, you know that if it's a rectangle, opposite sides are congruent. That means if this side on the left is x, this side on the right is also x. What do I know about the side above? I don't know anything about the side above because they're not necessarily equal, right? If they are equal, we call them square. I found a typo. Can you change that to suppose? Not suppose. So, is there any way for us to write those top and bottom in terms of x? And the clue that we know is that Lorenzo has 100 meters. What can we do? So let me try something with you, okay? So what I want to do is I want to find out this side. Let me go ahead and highlight it. I want to find this side that I'm highlighting in red. This side is going to be the same as the bottom right here, right? We just don't know them. We don't know what they are. So how about I temporarily call it something? How about I call it something? My name is Sue, so I'm going to go ahead and call it S. I'll just call this side S for right now. If the top is S, the bottom is also S, right? Because it's a rectangle. Now, if Lorenzo has 100 meters, what we know is that if he, if he's maximizing, if he's using all of his 100 meters, if we add up all these four sides, right? So if you go around, if you add x plus s plus s, that must equal to be what? That must equal 100 because that's how much he has, right? So I will set up an algebraic expression here, okay? If you add up x plus x, the two sides on the left, and if you add up s plus s, the two sides unknown, that should equal what? that must equal 100, and 100 is how much he has. If he had 200 meters, the right side number would have been 200. Okay, let me combine some like terms here, okay? X plus x is 2x, s plus s is 2s. And that makes perfect sense, doesn't it? Because we have 2 of each side. What I'm trying to do is I want to solve this for s. Why? Because I want to solve this for s so that I can plug in or substitute the s with an expression that only has x. I want to get rid of s. So what I will do is this. I will move this 2x to the other side. Then I will have 2s equals negative 2x plus 100. And I can divide everything by 2. If I do that, the unknown side s is equal to negative x plus 50. So watch, I am going to get rid of these unknown variable s. No more s. We know what s is. S is equal to negative x plus 50. If that side is negative x plus 50, the bottom side is also negative x plus 50. I'm interested to know how Alex will ask you these questions, or I'm sorry, how they will explain these questions. So this is just how I solve this problem, but if you guys are watching Alex videos and if you feel like they're having a really effective way of doing these problems, let me know next week, okay, when we are having our class meeting. All right, let's go over to part A. A function, find a function that gives the area. Now, we do know that area of a rectangle is length times width. We know the length and width here. Length is x, and width is negative x plus 50. So let's find the area function by doing x times negative x plus 50. That is the equation, and we've actually found it. But I want to go ahead and distribute the x because I want to write this in standard form. So a of x, the area function, is equal to x times negative x is negative x squared. Okay, next, 50 times x is 50x. So that is what I will circle, and that is probably what I will give as my area function, because I can identify what my a is. A is equal to negative 1, and b is equal to 50. A and b are useful if you want to find the vertex, right? Because look at the next question. They're asking, what side length x gives the maximum area? Whenever they're asking you for these maximum or minimum, you find those vertex, okay? X equals negative b over 2a. You use this so often, you probably got this memorized. The numerator will be negative b, so negative 50 over 2 times a, and a is negative 1, so I'm doing 2 times negative 1. This will turn into negative 50 over negative 2. If I divide, I will get x equals 25, and the unit was meters. Hold on a second. My keyboard just popped up for no reason. Let me go back down. I'm sorry. And when I'm done with this, this video, and the next one, I will also go ahead and put the completed notes on Canvas for you. So 25 meters. So what we know is this. If you have a rectangle, this side is 25, this side is 25. We don't know the other side, but we should be able to find the other side, right? We said the unknown side is negative x plus 50. So I can use that to find that unknown side. What that means is this unknown side, I should have used u for u or something, negative x. When x is 25, that becomes negative 25 plus 50. If you do that, negative 25 plus 50 is 25. Oh my goodness, look at that, guys. So we were assuming this was a rectangle. Well, what is, okay, it is a rectangle, but it's a special rectangle, isn't it? When all sides are equal to each other and rectangle has all congruent angles. So this is actually, we're actually looking at a square. So if you want to maximize an area of a rectangle, it actually becomes a square in this case. Okay, so what is a maximum area that the field can have? Well, area is equal to length times width. I know the length is 25, and I also know the width is 25. So I will say area is equal to 625 square meters. Or if you just want to use the area function, that's also okay. You plug in 25 into the function that we found. And if you evaluate it, we should get 625. Let me see. Negative parenthesis 25 squared plus 50 times 25. Yes, that comes out to be 625 meters. Both methods are perfectly fine. Up to you. I like to draw pictures, you know me. So I like to draw my rectangle, figure out the measures, and actually do length times width to find the area. But this is how you can do this problem. Now we got two more problems to look at, two more word problems, example 4 and 5. But those are a little bit more challenging, so I will come back. I will go ahead and first process this video, okay?